Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. Russell, thank you for joining me on the Analytics Engineering Podcast.
Yeah, thanks so much for having me.
This is going to be a fun conversation. You spend a lot of your time these days thinking about Iceberg, about Polaris. So I'm excited to quiz you on all related things. I wonder if you could start by giving the audience a little bit of a background on how you found yourself into this very specific niche of high volume analytic data file formats.
That's super interesting because I feel like it's a question I get a lot, and it's I find it hopefully illustrative of how random it is to be in computer science and to end up in a position where you're in any particular field or any position of power. I started my career at a company called DataStax, where I worked on Apache Cassandra. I started out as a test engineer, and I got quickly drawn into analytics. And the reason I did is I saw these big compute clusters, and I thought that was just really cool. And I really wanted to be involved in that. So I just, whenever it was possible, I would work on the analytics projects and things that we were doing there. And while I was there, a very clever coworker of mine, Piotr, saw Spark 0.9 being released and was like, it'd be really cool if Spark and Cassandra had a connector. And he started working on that, which got me into Spark, which then meant over the next 6 or 7 years of my career, I spent all this time thinking about how you move data back and forth between Cassandra and Spark and getting it to other systems. And the whole idea of interoperability of data sets over these distributed compute frameworks was like really appealing to me. I thought it was super cool. And during all that
pre-Apache Arrow.
This is a long time ago. This is pre any table formats. So we were just putting Parquet files everywhere and no one had any idea what they were doing. I mean, pre-Spark, we were busy being like, you know what, maybe a Lisp-like dialect is the right way to interact with distributed compute systems. And, I don't know if you remember Apache Pig, but like that was a thing that people were spending a lot of time on. Until we've come back to, I think, the perspective that no one understands anything but SQL, so we're going to stick there for our end user interface. Anyway, so I worked there, and I decided after a while I wanted to try something else. I knew a lot of people who had gone to Apple, so I decided to apply to Apple, and I applied for the Spark team at Apple. And I'm talking to all these engineers,
like helping build Apple's Spark infra, or like working directly on Spark, or what?
So they have an open source Spark team as well as like a Spark as infra team, and the two teams like work together. So I was trying to get onto that open source Spark team, trying to push the things that Apple would think is important into the project and supporting them and running Spark as a service. But when I did that, one of the people who interviewed me was Anton, who, if you look in the Iceberg roster, that's another Iceberg PMC, and he convinced the hiring manager that I should join the data tables team at Apple. And the data tables team was the Apache Iceberg team, basically. And they, very ambitiously were planning on trying to replace, everything that was at Apple with Apache Iceberg. And I didn't know anything really about the project at that time. But, I was like, that sounds like a fun thing to do. I've never heard of this. I'll learn all about it. And,
did Iceberg exist at that time, or was it some kind of Iceberg precursor?
This was Iceberg like 0.13 or something. It was very early in Iceberg. I'm probably getting the versioning wrong.
I actually don't know when Iceberg first, are we talking like 2018 or what?
Oh, I think the official start of the project at Netflix is 2018 or 2019. I can't remember. Okay. And then 2020 is when I joined Apple.
Got it.
So then at Apple, it was all Iceberg all the time. We were this scrappy little group that was trying to convince everyone to stop using what they were using and use Iceberg instead and get on board with all of our, open source as a service platform stuff to save everybody money, get off of technologies that don't really handle ACID transactions and stuff like that and into something that actually works. And we were super successful. We ended up.
That's interesting. Migrations are not easy. You folks must have made this accessible to teams.
Yeah, I mean the key thing to really make it accessible is that we were replacing complicated kind of bespoke solutions with
Mm,
Apache Iceberg. So the one of the most common things is you're running Hive. And when you're running Hive, you're running the Hadoop system, you might get small file problems and things like that. And everyone is writing their own custom implementations of compaction and locking and all these sorts of things to make sure that their system performs well. And it turns out not having to maintain that is a huge benefit to folks. So, we were able to make a good case because we basically say you don't have to worry about this anymore.
okay, so that makes sense. It's a different conversation when the trade-offs are, do you as a team like use Unity or Horizon or Iceberg versus like, are you rolling your own, Parquet wrappers?
Yeah, I mean, the question is like a lot easier, I think, for smaller teams. For organizations like Apple, it's always like, we're about to make an investment which will, if we go through with it and it saves money, will save a tremendous amount of money, but it will require us to put in some amount of engineering hours for basically the rest of the time we want to use this format, which means that that's a budget that goes on forever. Whereas
Mm,
smaller companies, when they're making these decisions, at least I feel like they should be, need to look at instead, how much of this can I offload? Like how much of
mhm.
this runs without an engineer being a big part of the runtime. So when you talk to people about migrations at these bigger companies, you basically are saying we're offloading your individual team responsibility onto this shared team responsibility. And for smaller companies, you're trying to say we're going to offload this complexity to maybe software as a service that someone's going to run this open source. And the reason that we want you to do open source is because we're basically going to make sure that you're never locked into any particular combination of other technologies. So you can always kind of make those moves as you see fit. But that's basically, I think, the big migration stories is how can you do less on your end, because almost no one actually gets paid to do data infrastructure. You know, we mostly get paid to provide business value, right? I mean, that's the story of DBT, right? Like you could manually be writing all of this pipeline code yourself by hand, but that's not what your company does to make money. So it doesn't make sense to have that as a homegrown thing. Same for table formats and file formats and things like that.
So okay, I've now spent the last decade of my life making open source software, but I have never been directly involved with an Apache project. So I am, and I don't think I've gone deep in the kind of maintainership story with anybody who is on the podcast before. So I'm very interested to. I think you first became a PMC while at Apple. Is that right? So can you tell me, like, what's a PMC? How does a project run? And any of this stuff. I'm fascinated by all of it.
Yeah, so Apache is really interesting because it's basically when you completely are giving away authority over your project to a community. So the Apache projects that are out there are all ostensibly not owned by any one company. And instead, the way that you exercise influence on a project is you become involved in that community. And the people who are already in power, who are on the PMC, which is the project management committee, recognize you and give you the ability to merge PRs or things like that, or join the PMC itself. And because those people are the ones who are controlling the project, as they move to different companies, the control over these projects, shifts drastically, because every one of those people basically is always thinking like, I may go somewhere else, but this project stays with me. So I focus on trying to develop this project in a way that makes it as popular as possible, it as functional as possible, and benefits everybody. So Apache is really interesting in that way, as opposed to some other foundations or other ways of doing open source software, because you basically say, I am just one part of this, and there's no CEO of this project who can decide what's going to happen next. There's no company that can say, like, we're not going to do this or we're going to change the license. Just cannot happen.
You
So
like
it's
that?
very different.
I find this all so fascinating because you were talking about the how the the PMC members really have a lot of control as they switch companies and all this stuff. It is. Do you think it is true that if you look at the Iceberg PMC list, which I don't know, it's like 20 people, 25 people, something like that?
Yeah, it's something like that.
Are they all, to the best of your knowledge, paid by some company to write this code? Or there's this idea that open source developers like live in their parents' basement. But that's not real.
I don't think it's I think the thing is, I don't want to say it's not real, because I would like to say it's like maybe 2 or 3% of like open source developers are not being directly paid to do the work they're doing to maintain the software. Like, it's a very small pool. There are very few projects where it's just one person who's super devoted to making sure that this thing works and maintaining everyone's contributions. I think in most really successful big projects, the ones you know the names of, like Spark, Kafka, Iceberg, these are Flink, these projects are effectively maintained by employees of companies who have a vested interest in that software continuing to work with whatever they're doing, either their software as a service or their frameworks or their engines or whatever. But they want to make sure that they have a voice at the table when those decisions are being made. So they hire people to work on those projects and hopefully gain merit and gain a position of control on the project as well. So it's very different than the way other software is developed.
So it is very fascinating because, okay, if you, even at DBT Labs, where we build DBT Core and publish it under the same license that Iceberg is published under, still it's not an Apache project, and so we control the roadmap. And so the relationship of the people who are the maintainers to the company is very much like a traditional company employee relationship. But it feels like it would be hard. Like, I can't even imagine what your performance review looks like, because like you're like not working on the Apple software, or now to skip to the current chapter, the Snowflake software, and I don't think like you probably report to a manager who can just say, look, Russell, you now need to implement this next feature, correct?
Yeah, I mean, that's a lot harder. So the way it usually works in these sorts of scenarios is you kind of talk about the capacity at which you will monitor what's going in the project. That's a big part of your OKR, like making sure that if things are being proposed, you kind of know where the product is going, what's being delivered, who's interested in working on what. And then internally, you're looking at what your company is doing and what they want to provide to users and seeing how does that fit into the project? Who can you convince to get on board? It's far more negotiating. You have to have a lot more on your OKRs where you're like, we will make this proposal. We will attempt to enlist people to jump on board. We will find out what compromises we have to make this happen. And Iceberg is a great example of this, because almost everything we do in Iceberg, if it doesn't work with every vendor, every engine, it's kind of pointless. Like, if we made something, I mean, I work at Snowflake right now, right? Yeah. If I made something that only worked for Snowflake, then who would care? Like, that's not valuable to Iceberg as a community. No one would do it. So whenever we make changes, we're trying to say, like, okay, if we do this, how will everyone react to this? How will everyone be able to deal with this change? Will it improve everyone's experiences? Will it make interoperability easier, or will it make it harder? Like, will it lead to a fragmentation of the community? So that's kind of what everyone is on board for trying to do. So it's kind of like a consortium developing like the HTTP standard or something like that. You have people who have vested interests in it working for everyone. And the good thing about having everyone at the same table is you can act as a counterbalance against things that where you're like, well, that actually won't work for this particular language or this particular engine. We get that all the time. We've run into things where we're like, oh, you use Java conventions for all of that, but like that won't work at all for Python parameter names. Like, we can't have this kind of syntax everywhere. It just won't pass any linter and break everything. So,
there is a point where somebody gets to decide whether this pull request gets accepted or whether this architectural decision, like, do you get together with the other PMCs and you all vote? How does that work?
So the general rules of Apache as like a foundation, we're supposed to be consensus driven. So you're really never supposed to have to vote for a code change. Like, you're supposed to always have everyone agreeing before something goes into the code base, or at least no one objecting strongly enough. So every member of the PMC theoretically has a veto on any code addition.
Mm.
But in practice, this ends up being very, very rarely used. Like it's supposed to only be allowed to be invoked in case of a technical disagreement. So like if 10 people in the community all really want to add a feature and one PMC member thinks like, oh, well, that's just a bad idea. Like I think we should do something completely different, or that's the wrong direction for the project, that you're not actually allowed to block in that case. You have to
Interesting.
have some reasonable thing like, oh, this will create a security hole that we will never be able to patch, that will limit the project's development. But
Got it.
you're theoretically not allowed to block, changes that just change the project in a direction that you don't agree with,
Got it.
mission statement or features or things like that.
Okay. So, and thank you. I could, one day buy you a beer and ask you a million more questions about this because I think it's so interesting. I mean, Apache is like legitimately an important institution in like the era of the internet and of software. So it's cool to see how they've done that.
Yeah, I mean, I'd be glad to talk more about it if you want to hear. But it's basically, you can imagine it's a committee of very smart engineers who all get together and they have to talk out their differences all the time.
So if we zoom in on Iceberg a little bit, I think that it transitions naturally because there's this, you mentioned Netflix before, you mentioned Apple. Sometimes, or I think maybe even commonly, the projects that move to the ASF originate inside of quote unquote big tech. And then a lot of times it is big tech that has the budget to continue to invest in them and employ the PMCs. And I'm curious how you view Iceberg as a result of that. Like, what does success look like? Because, my guess is if you look at the top 20 tech companies in the world, my guess is like probably some appreciable percentage of all of them have meaningful investments in Iceberg. But then if you look at our usage data, and Iceberg adoption is going up, certainly, but it's still something like, I don't know, 1% of the DBT community uses Iceberg. So like, is your collective goal to support the 20 biggest tech companies in the world? Or is it like, we want literally everyone using Iceberg?
I don't know if everyone needs Iceberg. Because I think
Okay.
there's a lot of use cases for which it's unnecessary to have this kind of complexity for a data format. I mean, then there's obviously OLTP data use cases as well, places where it makes more sense to use something like Postgres or something like that.
Sure, but just from an analytical perspective.
Big world. From an analytical perspective, I would hope that no one is using raw Parquet files in the next few years. I would love to get to a spot where your data at rest always has a little more structure to it than the way that we kind of saw like between 2010 and 2018 or whatever. Because I don't know if you remember those days, but basically everyone was building these Hadoop data lakes, and you were just dumping tons and tons of files into places, and no one could ever keep track of anything, and schema evolution was a mess, and you just ended up with broken tables. And I feel like we still are kind of working our way out of a lot of that legacy kind of thought on how to build things. But I mean, I've even talked to people where I'm trying to get them off of like CSV files into Parquet. So there's a broad spectrum of what we're going for. And I think we can at least agree that CSV is probably not the ideal form for storing pretty much any amount of machine readable data. We've got better options. And I think we'll probably get there eventually. Like, I think we would have, if we looked back far enough, we would have seen everything as in text files with no encodings at all, and like CSV and things like that, where you're relying on some very specific language layout to decrypt your files and get what data's in them. When I was in grad school, we worked with a format designed for protein crystallography for 3D structures of molecules. And it was a Fortran based system. So it was like column 1 and column 2 are the amino acid type, and then column 3 through 10, and like you end up with these really complicated bespoke formats that only work with one system and don't have good encoding. And now we're at a time there where we've kind of figured out at least how to do relational data. We at least kind of know that it should be in a machine specific format that supports different kinds of encodings and is extensible. And I think we'll be the same way for table formats as well. Like we're going to get to a spot where people just don't have a raw Parquet partition table where the folder names are the way you access partitions. Like I think that's kind of going to go by the wayside eventually. That would be my success. Is those use cases have migrated over to real table formats.
So that's the like lake moving to the lake house is kind of the direction that you're coming at this from, which, you know, I fully supportive. The other part of this is like the warehouse moving to the lake house. And so, you know, historically, if you looked at more structured data systems that look more like databases, you know, the storage was tightly coupled with the compute and, you know, the other 14 tiers of a database. Are the ways that you folks think about the Iceberg roadmap, are they mostly like helping people who used to be on pure Parquet and CSVs and all of this? Or are you also thinking about people who were locked into, you know, one database and they want to go multimodal or something?
Yeah, we're definitely thinking about those folks as well. I mean, it's that disconnect between hardware and storage, or compute and storage, is just so monumental in like how it's changed things recently. Again, a big change from the Hadoop era where I've spent a lot of time. If you look up my name, you'll see a lot of talks where I talk about how co-locating certain types of applications like Cassandra nodes and Spark processes can do way better than talking over your network. And that kind of stuff just like doesn't matter anymore because everyone is now in this cloud space where your storage is basically infinitely elastic and not really local to anything, and your compute is also elastic and also completely separate. So we don't have the same design considerations. I mean, it's one of the things you look at a lot of these formats, like including Iceberg, and we have like some default split sizes, default Parquet configurations, which are basically tuned around HDFS defaults. And we have almost no one using HDFS as their main storage. Now, even people who are using HDFS usually put some kind of S3 compatibility layer on top of it, so it actually looks like S3 to all their clients. And that kind of throws out all these I/O assumptions that we used to have. Like, does it make sense to have a 128 megabyte file when you're in S3? I mean, maybe not, because who really cares? Because our I/O operations are kind of unrelated to how we have laid out the disk logically, or the memory logically, because the S3 system itself is going to lay it out in some way that only the current AWS engineers are going to know.
Right.
And we basically have to do all these different IO patterns and things like that. So I think that's a big change, but I do think everyone wants to move in that direction because the ability to decouple those two things is huge. No one wants to pay for compute on storage, have them so linked so that you're always paying for your compute just because your storage went up or something like that. You want them completely decoupled.
I'm, running the risk of asking you to go way too deep. So I'm going to ask a question, and then if we end up diving way too deep in the rabbit hole, I'll pull us back. But I am interested in the evolution of Iceberg at a technical level. There has been V1, V2, V3, and now I think you're primarily working on V4.
Working on V4. Yeah, I can describe this at pretty high level.
What are the big arrows of progress?
Why don't we like kind of break it into like use cases, which is a kind of how I think about it sometimes. So like V1 of Iceberg is basically I have Hive. I have a transactional analytics table, and I would like to store it somewhere with real transactions and with less IO. So the big use case is just that basic ETL kind of thing.
The transactions have been in since the very beginning.
Yes.
Okay.
And then V2 kind of takes us to the use case of GDPR compliance. So the big feature of V2 is row level operations, the ability to more efficiently deal with the fact that sometimes we have to delete one row in a file that has 10 million rows. And previously in V1, the only way to do that would be to copy the entire file minus that one row. So V2 added the primitives that were required to do that without recopying the entire file.
Physical
so you basically
delete or logical delete?
Basically, you do logical delete. So you add in a file that basically marks which rows in the existing data file have been deleted as of a certain point in time. This is where I didn't want to get into too much detail.
But like for GDP, because you mentioned GDPR is a big use case. I think logical deletes are insufficient but maybe during the next maintenance operation.
Yes.
Yeah.
So basically, you can accumulate these point deletes, and they appear invisible to couriers. They can't see the missing data. So as long as your system is shut down, you can have that. And then eventually you do have to completely purge them from your system. But now you're aggregating those together. So instead of doing it live every single time, which would require copying the file over every single time, you aggregate your deletes. The view is correct. And eventually when you do compact, when you realize those deletes, they are physically removed. So basically a whole new set of use cases opens up in V2. I would say V3 is our first big step into other use cases. So geospatial types get added, variant data types get added. We add in these types that basically let you start doing semi-structured data and geographic data and kind of opening that up, because a lot of relational systems already have built-in geospatial types or built-in like semi-structured types. And this is bringing those into Iceberg as well. So now Iceberg has kind of expanded out to be able to handle just a wider variety of data analytics use cases in these other spaces. I think V4 looks to me...
before you move on to V4, I was just talking to Chris Child, whom I assume you know. Yeah.
But yes, he's tells me what to do.
Yeah, okay. I think he was talking about you folks contributed a lot of work on the variant data type. Is that right?
Yes, it was a huge collaborative effort, of course, like all of these things have to be. But there were folks at Snowflake and Databricks and Google and Amazon, and we're all together and just yelling about how this is going to be. Because again, we want to make sure that when we have it done, you can take a file that's written by any of these systems and read it in any of these other systems. So we have to get it in a place where everyone can have full agreement before we all start writing them, or you end up with a split in the format.
Is variant actually specified in the SQL spec anywhere, or is that like a thing that is purely of industry?
Man, you're
did you guys like invent variant from scratch and everybody had to fight about what it even means?
Variant as a concept has existed in a lot of like warehouse systems and things like that. I would say there is prior art for it. The specific variant that we are using in Iceberg comes initially from some work that was done at both Databricks and at Snowflake, because Snowflake has actually had a variant type built into their format for a very long time.
Yeah.
And they were like, we want to be able to have people have the option of using Iceberg, but also have variant. And Databricks folks similarly had that view, and they also want people to be able to use variant. So working together, you kind of come into agreement and you decide on something, and we got it moved into the Parquet project. And now there's just a well-defined variant type.
Oh, interesting. In order to get a new data type, you can't implement that. You have to go down to Parquet to do it.
Well, you have to at least have some file format that supports it, because otherwise the Iceberg spec itself doesn't tell you how to binary encode anything.
Sure. So what is it? You like primarily work with Avro, Parquet, and something else?
Avro, Parquet, and ORC, although really Parquet is the one that gets the most love. The other two do not have the same backing. But the Iceberg spec will say, like, this is a type we support. We support an int. We say the int is going to be, 8 bytes wide. That's it. Or something like that. And then the file formats then have to have a conversion of whatever their underlying type is into the Iceberg type. So you end up with file formats that have definitions of types that need to go to Iceberg types. And then the engines that are reading this, like Spark or Trino, might have their own type representations, but they only have to understand Iceberg types. They don't have to understand the file format. This is actually a little more complicated than that because almost all of these engines have custom readers, so they kind of bypass that. But this is how they
Mm,
know what type they should be reading as,
mm,
because they'll look in what Iceberg says and then read it based on that type definition or do
got it.
type modification if required.
Okay, V4.
So V4, I think, is going to be our big kind of streaming push to kind of make Iceberg
Interesting.
a better fit for a lot of streaming use cases. And since we still have a lot of time, I think it's also going to be our big push into AI specific use cases, because we know there's some spots in Iceberg where it simply is not a good fit for some of the kind of operations that AI users kind of expect. And this is probably not for the folks watching this podcast particularly, but for people who are building their own like AI services where you have to store huge amounts of vectors and
So I was
image
just
data and
talking
things like
to
that.
Chang She of Lance.
Mm-hmm.
Um, I note that Lance is not currently one of your supported file formats. I don't even know if that is, but like in order to solve some of these AI problems, isn't it partially a file format problem?
That's a really good question. So there's a question of whether it's a file format problem, a table format problem, or actually even a mix of the two. So like
Hmm.
LanceDB has both, right? They basically have to attack it at both ends
Hmm.
to get that solution. And we're exploring some approaches now on like whether or not this should be a change in Iceberg alone or something that Iceberg and Parquet simultaneously do
Hmm.
with changes on both sides that end up with a similar kind of outcome. But we're heavily aware of the things that you cannot currently do within Iceberg that you want to be able to do with these kind of AI use cases, and we're actively trying to figure out what the best solution is, without, of course, throwing out all the Iceberg tables that already exist. So hopefully, we end up in a world where we just have those capabilities. I mean, it's similar with V3. We're looking a lot at other systems that look like Iceberg, but maybe do better for streaming use cases. And just being like, well, why don't we just take those bits that we think make sense and make Iceberg better for those use cases? So, it's basically the evolution of the format is where can we get consensus amongst everyone? We can all agree that this is how we will do it. And then widen that user base of Iceberg even more.
Yeah. Say more about streaming. I took you down the AI path. What does it mean for Iceberg to be better at streaming?
So the main things that we need to do to be better at streaming, I think, are the latency of the commit process. So this
Mm,
is getting a little into the weeds, but the way Iceberg works requires a lot of files to be written before
yeah,
a
yeah.
commit happens. So for
If
very
you read
low
the original Duck Like post, they really love to talk about how many.
yeah, I mean, it's got a lot of spots there, which you know, we're talking about maybe 100 milliseconds or something, but it's, we would love that to not be that many seconds. So we would love to get to the point where it takes only a single file write to actually do that final commit process, while the preparation is still very expensive. I mean, that's one of the things here is that Iceberg's originally written for this use case where we expect that the time writing data files is like 10 minutes, 10 or
Yep,
20
yep.
minutes.
It
And
arose
then
out of
you're
the
like,
batch-based Lake environment.
yeah, and then you're like, so your commit takes 100 milliseconds instead of 10 milliseconds. Like, no one cares. But when we start getting these streaming use cases, we're ending up with people who are like, well, I want to write, every minute or every 5 minutes. Now it starts to add up, and we really need to start cutting that time down because they're going to spend most of that time writing data files, and then they need to commit as soon as possible. They don't want to have to do any kind of retries. So that's another big thing in our V4 proposals. There's a huge one out from us and from Databricks that we've kind of merged them because we both kind of have the same ideas, where we're going to try to make it so that the retry process, so if you attempt to commit and you were beat out by some other committer, you'll be able to retry much faster. So the way that it's currently set up requires you to do basically a bit of recomputation before you can attempt to commit again, and we're going to try to reduce that as well. We're also looking in the catalog protocol itself to try to figure out, can we send the information about what's changing in the table in a way that is easier to deconflict. So currently the deconfliction mechanism in Iceberg basically says, if you
Retry.
changed from when I tried to commit, just retry, and you figure it out. Whereas in the new commit protocol, and the way that we're thinking about things in the Iceberg REST API, this is our catalog API, we're saying, what if instead you say, like, I need to add these 5 files, and when I add those 5 files, these 3 other files better still exist. And after you add these 5 files, delete those 3. So this would be like conceptually describing what it would take to like replace those 3 files with new data. And then having that deconfliction happen at commit time rather than on the client. I don't know if that made sense, but basically the way it works now is we only save the end. We're like, oh, we made state A. Are you still at state B? And if the catalog is not at state B, you stop, you go back and you make state C to be built on top of it. Whereas instead we would say, like, try to get to this next state. Here are the steps you need to do. Are any of these steps impossible right now? So big moves in the future.
Oh, geez. I think I'm going to leave that one alone. But gosh, I really want to. I almost want to go down there, but I think that would be a wrong turn. Okay, so we've to date been talking, or to this point in the conversation, we've been talking to Iceberg, the open table format, but you're also, I believe, involved in Polaris. Is that fair?
I am. I'm also on the PPMC for Polaris. So that's, again, that group of engineers who kind of makes larger voting decisions on the project.
Wait, what? PMC?
There's another P because it's the proposed, or is it proposed? Yeah, I think it's proposed project management committee. So Apache. See, now you're going to get me in the weeds on how Apache works.
When you don't know what
It's for projects in Apache. You don't get to just say, hey, I've got a project and now it's an Apache project.
Well, I'm sorry, it's PPMC because it's not a full-fledged Apache project yet.
Yes, it is an incubating project. So basically we're in the process of proving to the greater Apache community that we can operate like an Apache project. So they do the things to make sure that
it's not that you're trying to prove that the world wants Polaris, it's that you're trying to prove that that this group of people is able to do the thing.
So Apache is very clear about this. They do not care how many projects they have that do the exact same thing, unimportant, or how popular those projects are. The important thing for an Apache project is that it follows the fundamental principles of how an Apache project should operate. So it's doing things like making sure that you've given up all the trademarks. Like, you can't be an official Apache project unless you have given all the trademarks over to Apache. There are other foundations who, you've gotten in trouble with this, where like you say you can have a project join, and then at the last minute they're like, you know what, I don't actually want you to have the trademark. So now you have a project that the foundation owns, but they can't actually use the name because the trademark is held by a corp. Like this kind of stuff happens. So this is what the incubation period is for. It's, can you work as a community, multiple people working on the project, taking feedback from people in the community and allowing people to join, and making sure that you're only allowing things in based on merit. You're not excluding people based on where they work or what they think,
Sure. Okay. So for Iceberg and Polaris, the interface, I believe, is the REST catalog spec. Is that correct?
It's the thing I was just describing a little bit.
And now, who specifies that? I don't think Polaris specifies that. I think that Iceberg specifies that,
so
right?
Iceberg has written the Iceberg REST spec because we also write the client implementation, or at least we have one of the client implementations.
Sure.
So Iceberg REST spec basically has been defining, like, this is how this code base, which is essentially a client code base, will talk to a catalog and tell it what to do to make a commit appear. So all of those discussions happen inside of the Iceberg project with the same PMC that goes over the table format itself. And then the Polaris PMC is discussing, how will we implement that? How will we actually define how these things work together?
It is kind of an interesting relationship, right? Like, there's a different set of PMCs that get to define kind of the behaviors, the interface of your project.
Yeah, I mean, it's very similar though. I mean, it's you have very similar things on like Parquet and Spark and Flink and all these, because we have all these systems that work together, but
Hmm.
the
Hmm.
API boundaries between them have to be decided by one group and the other group has to react. Although many
Hmm.
times the people who are involved in all these projects are on all of these different boards.
Okay, so I noticed, like, you're on both of these.
Hmm.
Julian Ledem is on both Parquet and Iceberg. So like there's this connective tissue.
Yeah, you get a lot of people, and because I mean, one of the downsides of being this kind of community based approach is that everyone you know kind of gets pulled into your next project.
Mm-hmm.
So it's very kind of, you end up a little cliquish sometimes, and the same people kind of get involved in thing after thing after thing.
Hmm.
But it is one of like the active things we try to work on, is to try to expand that group to allow more and more people in. But you will often see a person on the PMC of several related projects because they simply worked on one and then they were interested in how it integrated with another, so they ended up
Hmm.
doing a lot of work there, and then they ended up with a position in that project, and you just kind of keep going there.
You can feel free to opine as much as you want on this or not. But I think it is very confusing to to me, the relationship between Snowflake and Horizon and Polaris. And there's internally managed Iceberg or like Snowflake managed catalog. There's externally managed catalog, which they hopefully you use Polaris, but you don't have to. And it just seems a little bit confusing. Can you deconfuse this?
Yeah. Well, I mean, hopefully we're changing things right now to hopefully make it much simpler to understand.
Oh, I didn't realize that.
And yeah, I mean, we recognize that the way things were set up are confusing, and we're working to simplify that and just make it a much easier decision for folks. Um, but basically, the way that it will look in the future is that there will be, either you are running Snowflake and Snowflake provides you this REST endpoints for Iceberg catalogs, or you're running your own Iceberg catalog, which could potentially be this open source Polaris, and then you're connecting to that. But Snowflake can connect to either itself or any of these other external Iceberg REST catalogs. So it really just comes up to, who do you want to manage your software, right? Do you want to be running Snowflake as a whole stack? And if you are comfortable with having Snowflake governance and all of that things on top of your catalog layer, you can talk to that using any other Iceberg REST client. Or if you just want an open source code base, but you don't actually want to run it yourself, there's a managed option of that. But again, Snowflake can talk to that, and any other Iceberg REST client can talk to that. And then finally, there's open source Polaris as its own thing. So if you want to run it yourself on your own hardware, you can do that, and Snowflake can still connect to that. So hopefully it'll be much simpler. It's
Mm.
not so much all these different terms. It's just, where do you want to run your catalog? Who do you want to be your catalog? And then everything works with everything else. I mean, that's
So
the big promise of the whole spec.
is it fair to say that Horizon and Polaris are two different code bases, two different things? And then the third choice is, do you want Snowflake to manage Polaris or do you want to do it yourself? Is that right?
Kind of. At some level, the Horizon support for Iceberg is Polaris based.
Oh, interesting. Okay.
Yeah.
So
So when you're running
you're upstream of
Polaris,
them.
yeah. So if you're running Polaris either managed by us or on your own, that is the same code base that's kind of backing up the support inside of Snowflake for Iceberg.
Interesting. But there's more layers
Yeah,
of.
there's, because it's still the complete Horizon package. So it's not just
Correct.
that; it's
Yes.
also
Okay.
all of the other things that Snowflake supports in terms of catalogs.
I understand that, as a Apache ASF, PMC member, like your job is not to see Polaris quote unquote win. Um, but you hopefully want adoption of this thing. What there's a bunch of implementations of the Iceberg REST spec. Um, do they are they different? Are they strong at different things? Are like, what are the decision criteria that someone would have if they said like, well, what implementation do I want?
Yeah, I think that's a really hard question. And as like this kind of back end dev engineer, I don't
Oh, yeah.
try to get into those kind of like debates that often.
Do you have an opinion on like what
Well,
Polaris is trying to
obviously,
be best in the world at?
oh, well, I believe Polaris is trying to be best at everything. It's a very long roadmap, but it wants to be that full Iceberg catalog, business catalog, support other table formats and file formats, like support everything.
Oh,
It's
interesting.
a
So Polaris
pretty
is not
broad goal.
exclusively to Iceberg.
No, so we already even have support for basically having your Polaris catalog act as a generic Spark catalog. So, like if you have Spark and you connect to Polaris, you can save every kind of data source into it that Spark supports. So you can
Hmm.
basically replace an HMS with Polaris if you're using Spark. But that's just one piece of this. So I think we kind of looking to provide that kind of lakehouse interoperable catalog that people can use and can also be that building base for what we're trying to offer to people inside of Snowflake. I know there's a lot of other projects, and I think the main differences between them are all very fundamental architectural ones, but I don't know if they're as user facing. So like, should persistence be treated like a key value store, or should persistence be treated like a relational database? Can you assume that the persistence layer can do transactions, or should you assume that you can't do anything but a check and swap?
Hmm.
Questions about should the catalog be responsible for policy enforcement or policy recording? Should it be responsible for tagging and identity? Like, there's a lot of different questions and where the catalog should fit in that. And I think the Polaris project is trying to get into a place where a lot of those things have a basic implementation but are pluggable, so that folks who want to use Polaris in some different contexts can do that. So, like for example, we have folks working on open identity provider interfaces and things like that. So it doesn't
Hmm.
just use Polaris native principles. You can actually hook it into like AWS or GCP or I forget what Microsoft does, Entra or things like that. And you can basically say, I'm using a completely different identity provider. That's where you should be getting all those decisions, things like that.
One of the things I wanted to make sure to hit with you while I had you was identity, because it does seem, we were talking before about the like however many tiers of the database you want to enumerate, and while certainly Iceberg itself is an important layer, the catalog layer is this like really messy thing to
Yeah.
to determine like how much scope do you want to give it, because it can like expand out to
Uh-huh.
include like most of the database.
It is wild. I mean, I've seen a lot of people use terminology of like business catalog versus like system catalog and things like that to try to differentiate some of these ideas. And of course, people are talking about like semantic catalog now, which I feel like is
Mm.
combining even more of these ideas together. But um, Polaris is definitely trying to stay on the system side of things, but we'll see what happens as time goes on. I
Where
It's
where does
hard.
the where's the scope line in terms of identity and access
So
control and all this stuff?
that's the hard thing. So like, it's hard to define access control without defining how you actually access the table, right? So you need to have those things connected, but then there's this whole different notion of how some people work with catalogs where they're like, well, for data discovery, I don't need any notion of what is available or how to actually get it. I'm just actually cataloging all the data sets that are, and instead I have like a note that's like, if you want to access this, you talk to team whatever. And for that catalog, you need no information about how the underlying tables work. You just need to know all the tables that are available and have access control. But the access control is just about listing and showing. It's not about reading and loading. So we have that's what I would consider like the business side of things, where like those capabilities have to exist. But if you want to do actual access control on the data itself, then it has to be a part of the catalog too. But then it's a system catalog. So it has to actually know, how do the files get laid out? Like, what does it mean to have a table that you can grant access? So, like in the case of Polaris, the way we do, S3 grants and things like that is, if you want access to a table, we basically give you a credential that says you can access the directory which this table has files in for that particular load operation. And that credentialing, like vending of that credential, can only be done if we understand how the table is laid out. Like, you can
Hmm.
imagine
Hmm.
a system that supports a relational catalog can't vend credentials in that same way without understanding how the data is laid out. It probably instead has to do some kind of like user impersonation or something like that, or delegate the decision to the other system. So actually accessing the data always makes things more complicated, but that's kind of the side of what we're doing in Polaris, is a catalog that knows how data is actually laid out for most of the things it does.
I am increasingly of the opinion that it is going to be this set of things that I don't think prevents Iceberg adoption, but maybe prevents it from being kind of the mass market default of like how everybody just chooses to do everything.
It could be. I don't know. For me,
I'm sorry.
I think,
at least over the next couple of years, like we're still figuring some things out.
Yeah, I think we're getting to. It's always weird what used to be considered really complicated now is so commonplace that we wouldn't even think twice about it. Like right now, if I told you I had a data set of Parquet files, you'd be like, of course, everyone has a data set of Parquet files. But if I told you that, 15 years, or that's too long ago, I'm trying to remember the early days of Parquet, you'd be like, well, why aren't you using ORC files or something like that? Like there's things change, and what used to be completely unexpected and impossible to deal with is now totally normal, and everyone just assumes it. Like,
yeah,
all your data files are compressed, have modular compression or things like that. I'm sure encryption is going to get there sooner than later, where everyone is just like, well, of course, all of your data files are always encrypted. Why would everyone ever not do that? We have all of our data on the cloud. We're going to encrypt everything so that our cloud providers can't look at our data or whatever.
Well, I'm looking forward to just the way that the team from Databricks and the team from Snowflake got together to agree on a variant data type that like everybody agrees that like this is how we map users between systems and how we understand the grants to the data and all of this. Like
that one is getting easy, harder. We have a lot more strong decisions there, but
yeah. Well, Russell, this has been a lot of fun. Thank you for joining me today to share the inner workings of Iceberg and Polaris development.
All right. Well, thanks so much for having me on.